Hey everybody. So I had a couple of people asking me questions the other day about multimeters, voltage, amperage, resistance, different things like that. If you're new to messing with electrical stuff, it's really nice to get a little more information and practice with it so you can better apply it. It'll get you out of a lot of trouble when you're wiring so you understand better what you're doing. Now we're going to talk about multimeters and some basic uses. We're not going to go real in depth in them, just kind of explain it, give you a quick overview. Now, this is just a plain Jane multimeter. There's nothing special about it. This is the equivalent of one you can buy like at Lowe's Home Improvement. I prefer the digital ones. The analog ones work fine, but the needle is kind of hard to read, and it's nice with the digital. You can stick it far away, especially one that's illuminated, and you can read it real easy. Now, there are two different voltage settings. You'll notice DC and AC. Automotive world, most of the time, you're going to be using the DC setting, direct current, which is usually indicated by straight lines next to the voltage symbol. Now the AC, you see it's got a little squiggly, reads a little bit different. So you got to make sure that you're plugged in the right ports at the bottom. There are usually 3 different ports. COM is typically your ground, and the other port is for voltage, resistance, continuity, and for temperature if you have a setting like that on your meter. The amperage setting over here says 10 amps on it. If you're checking for amperage, you can check up to 10 amps with this multimeter, but it only has a 10 amp fuse built into it. If you check something that's over 10 amps, you run the risk of blowing the fuse or hurting your multimeter. And at that point, that's when you need to run an amp clamp or an external device on here to read higher amperages. But for your typical automotive use, this is perfect and it'll get you most of what you need. Now, we're going to show you a couple different things here on voltage, and then we're going to go over resistance and continuity and their differences and how you can apply them. All right, so we have our ground lead connected. Now I got the vice grips on here just because I'm doing this by myself, and it's hard to hold a camera and do it all at the same time. You're getting a millivolt reading with it set on DC. Now, if you're getting millivolts, that means that nobody's home. You can see as soon as we touch our positive lead, we're getting a reading of 4.05 volts. Now, that just indicates that our battery has no charge on it. Now, this is showing how much voltage is on it. That does not necessarily mean that it is a good or bad battery. In order to check batteries correctly, they need to be fully charged, but this is just to show you a voltage reading. All right. Now, you can have the leads hooked up backwards, and in that case, you would get a negative sign here, and that lets you know that you got your ground and your power backwards. So right now, we have it set to ohms. So you can see we're reading OL, 0.L. Now, this indicates open. This is if you have a broken wire or a wire that is not connected or just has infinite resistance. OL is all the resistance, completely open. Now, always check your meter leads. You can see we're reading OL, but when we touch them together, all of a sudden now we're reading resistance. So this meter has an internal resistance of 1.1, 1.2 ohms roughly. So when you go to check a wire, like let's say this brown wire, you go to check it, you put your leads on it, you may connect to it and say, oh man, look at that, my resistance is a little high, I'm reading 1.2 ohms, when actually you're reading 0.0 ohms because of the internal resistance in your meter. Always keep that in mind. Try your best not to hold the leads on there like that with your finger, because in some cases you may get an incorrect resistance reading. Right now, we're not, but you can. Try your best not to hold your fingers on there. Also, when you're checking connectors like these, you can back probe and stick your connector in the back like that. And look, you're still making contact with it, and that's great. Do not pierce the wires with your test lead. Some of these are sharp. Some people sharpen them to pierce them. That is not good for your wire. That'll leave a hole there and leave you open to corrosion and the elements, which will eventually degrade the wire and cause poor connections. All right, so here's another meter. This is the Lowe's Home Improvement brand. So you have a lot of the similar readings, but this doesn't have an auto ranging on the ohms. You actually set it to the range you want. If you're going to be reading under 200 ohms, under 2,000 ohms, use it as like your max limit. Now we've got it set to continuity right now, and this is an easy way to test if maybe you can't keep your eyes on your meter. It'll at least tell you if you have a connection. So it has an audible squeal that it makes if you have continuity, so we can test it with our leads. It's a very faint noise. Then we're going to go over here and touch our wires. Let's see if we get the same reading. Now I'm just holding it with my fingers because I don't have that many hands. But you see, that shows you they have continuity. That does not mean that your wire is good. That just means that you have continuity between the wires. It still may be a poor connection. All right, so that was just a basic rundown on the meter. I'm not going to get real in depth in it because we can spend hours. You need to get out in the shop, experience a little bit, watch some YouTube videos, do your own research. Now, amperage, voltage, resistance, they're all different things. Just because something has 12 volts doesn't mean that it can handle the amp load that you're applying to it. If you use a small gauge wire like this and try to run your electric fans or your air compressor for your air ride suspension, guess what? It's going to fail. It's going to melt. Look at your instructions. Make sure you're using the appropriate type of wire, the appropriate gauge wire. Use good connectors. Don't use those cheap dollar store butt connectors. And if you use Scotch locks, I will hunt you down. Do not use Scotch locks. Do you hear me? Do you understand the words that are coming out of my mouth? Scotch locks are bad. Use butt connectors. And if you can, solder it and heat shrink it to get the best connection. Now, I'm going to go over some basic tools that I use that make my life a lot easier. Some people use wire strippers that you squeeze the wire in there and you pull. Well, these are awesome right here. These are automatic wire strippers. You literally just lay the wire in there and then squeeze it like that, and it strips the end of the wire for you nice and neat, and you don't have to adjust it for different gauges. It's a big time saver. They're not expensive. They range anywhere from $20 to $50 depending on the brand that you get. Now, these are what I use to crimp my butt connectors. And as you can see, there are two different notches in here. This bottom notch right here is for bare connections, ones that don't have any kind of insulation around them, and it's labeled as such. This top joint here is labeled for insulated connectors, such as butt connectors with heat shrink insulation on them. These will make a better connection than just using vice grips or some random pliers, and they do have cutters on the end. Now, there are different types of connectors, such as weather packs. There's different grooves in here. These are a ratcheting pair. They're really nice. And on the other side, as you can see, it's labeled for the gauge wires that it is appropriate for. This is another style of crimper for weather packs. It's just a little more mechanical, and you have different ends that you use for different style connectors. Now, there are different types of connectors out there. This is a non-insulated. Now, there are different types of connectors out there. This is a bullet connector, and it does have insulation on it, see? But you can't heat shrink this. It's a hard plastic. Now, this is fine for a connection inside the vehicle that's not going to be susceptible to the elements. However, if you're doing wiring outside your vehicle or under your hood, you want to use a connector more like this. This has heat shrink insulation on both ends, and this will keep you from getting water and other elements inside your connection, which will reduce the occurrences of corrosion and poor connections in your wiring. Now, also, duct tape and painter's tape is not what you use to seal an electrical connection, okay? Use electrical tape. Use heat shrink. Use any kind of protective looming when you can to protect from rubbing. Don't just bundle your wires together and twist them in a knot. Do them nice and neat and clean. It'll help you in the long run, and it'll make your car's wiring hold up a lot longer. All right, well, thanks for joining me. Like I said, this was just a real quick basic overview. If you have any questions or you're having any electrical problems and you think I can help you out, please email me at rustybrothersgarage@gmail or at greasyboycustoms@gmail, and I'd be more than happy to help you out. And if you want to, you can hit me up on Facebook too at Greasy Boy Customs. And if you're having questions about what to use or how to use or diagnosing an issue, I'd be more than happy to give you some of my time. And any advice or input on any other information that you may want to know or see a video about, please let me know. Thanks.